Hello students and good afternoon. So now I'm doing class for class 12. The topic is the same topic that we were doing in the last online class. So the topic is integration by the method of substitution. Same exercise 6A, page number 351, 5 marks section from the book Higher Mathematics for class 12 by Sailendra. And in the last online class we finished question number 23. So let's do this question number 24 now. So what is question number 24 here? You have to evaluate this integration, that is integral of, in the numerator, 1 plus sine x divided by, it is sine x into within bracket 1 plus cos x, then dx. Okay, so let us write here I is equal to, therefore I is equal to integration of 1 plus sine x divided by sin x into 1 plus cos x bracket closed dx. Okay, so now how can you evaluate this integral? In this case we cannot do method of substitution, because if you differentiate 1 plus cos x you will get minus sin x, but there is 1 plus sin x is there. You cannot separate the term here also. Okay, and there is sin x, is differentiation is cos x, but there is 1 plus sin x in the numerator. Okay, so let us use the formula from the submultiple angle in this case. Okay, so you know that 1 plus cos x is 2 cos square x by 2. You know the formula. And what is sin x? It is 2 sin x by 2 cos x by 2. And you know what is 1 sin square x by 2 plus cos square x by 2. So let us use the formula now. Or I is equal to integration of, instead of 1 you can write sin square x by 2 plus cos square x by 2 plus sin x is, this is 2 sin x by 2, this is cos x by 2, this whole divided by, what is the formula for sin x again? It is 2 sin x by 2 into cos x by 2 into, again what is 1 plus cos x? It is 2 cos square x by 2, and then what do we write here? Dx. Is that clear? So now what will you do in the next step? You can separate the term now, or let us separate the term here. I is equal to integration of, let us write it within second bracket. Now let us separate these terms. So it is sin square x by 2 divided by this denominator 2 sin x by 2 cos x by 2 into 2 cos square x by 2, right? This is the first term. Plus, what is the second term? Plus cos square x by 2 divided by, here it is 2 sin x by 2 cos x by 2 into 2 cos square x by 2. 2 cos square x by 2. Then what is the last term? Plus 2 sin x by 2 into cos x by 2 divided by, it is 2 sin x by 2, then cos x by 2 into 2 cos square x by 2 into 2 cos square x by 2. Is that clear? So second bracket is closed. Then what do we write? Dx. So I think you have understood it. Okay, so you can copy it. Now we'll do the simplification now here. So now let us simplify it. So here you can cancel this cos square x by 2. Here you can cancel this 2 sin x by 2 cos x by 2 will be cancelled. Okay, so here you can cancel this sin x by 2 and square will be cancelled. Okay, so now, or I is equal to integral sign within second bracket. Let us simplify it. So now it is what is sin x by 2 cos x by 2? So this is your 1/4, this is your 1/4, 2 2s are 4, right? Sin x by 2 by cos x by 2 is tan x by 2. This is tan x by 2, and this is what is 1 by cos square x by 2? This is sec square x by 2. Understood? Next, plus, this is 1. 1 divided by, what is 2 sin x by 2 cos x by 2 again? It is, you can write here sin x into, this is your 2. Right? Next, plus half. 1 upon 2. What is 1 by cos square x by 2? It is sec square x by 2. Then what do we write? Second bracket closed, dx. So I think you have understood it. We have simplified it. Now separate the term again, or I is equal to 1/4 is constant taken outside. Now you can separate this integral sign and dx also. Integral sign, this is tan x by 2. This is sec square x by 2 dx. Is that clear? 1/4 is constant taken outside. Integration of tan x by 2 sec square x by 2 dx plus. Now you know that this half is constant taken outside, and this is integration of what is 1 by sin x? Cosec x. This is your cosec x dx. Understood? So now last one is plus half is constant integration of, that is integration of what is the variable here? Sec square x by 2 dx. So we have got this expression. So I think you have understood it. So now let us simplify it again. Or I is equal to, how will you evaluate this integration? And the differentiation of tan x by 2 will be sec square x by 2. Here you have to do the method of substitution. Isn't it? Let us write it as I1. So let us write it as I1 plus half into, now you know that what is integration of cosec x? What is integration of cosec x? Directly you can write down the formula. You know the formula, isn't it? What is integration of cosec x? It is log within mod tan x by 2, mod sign is closed. Plus, next one. Plus, what is the next one? It is half. Half is constant, write down half into, what is integration of sec square mx dx? What is integration of sec square mx dx? That is tan mx by m. Or differentiation of which function is sec square mx? It will be tan mx divided by m. Here what is m? It is half. So tan mx here is tan x by 2 divided by, here m is half, divided by half. Then you can write plus c. So here you can cancel these two, cancel them. Or now it is I is equal to I1 plus half log within mod, it is tan x by 2 plus, what is the third term here? It is tan x by 2 plus c. But this is not the answer, because we have to find out the value for I1. Okay, so let us find out the value for I1 now. What is I1 actually? Which integration was taken as I1? It is 1/4 integration of tan x by 2 sec square x by 2 dx. So let us assume here, let I1 is equal to, what is I1 here now? I1 is this one, 1/4 integration of, this is 1/4 integration of tan x by 2, then what is there? 1/4 integration of tan x by 2, then sec square x by 2 dx, right? So it is sec square x by 2 dx. Now in this case we can do the method of substitution, because what is the relation between tan x by 2 and sec square x by 2? Differentiation of tan x by 2 is sec square x by 2 into half. We can manipulate that constant half. The constant half la hami eta uta minaunu sakihalchau. But we are getting the differentiation of tan x by 2 as sec square x by 2, isn't it? So let us assume let z is equal to, this is tan x by 2. So I think you have understood it. So now let us differentiate both the sides with respect to x. So differentiating both the sides with respect to x. So what do we get? So it is dz by dx is equal to, what is the differentiation of tan x by 2? This is in the form tan mx. It is sec square x by 2 into, again differentiate x by 2 with respect to x, that is your half, right? Or now it is dz by dx is equal to half, this is your sec square x by 2. Now let us find out, now from here let us find out the value for sec square x by 2 dx. Okay, now cross multiply by 2 here and you can cross multiply by dx there. So or it is 2 dz is equal to, this is your sec square x by 2 dx. So we have got the value of this expression, that is sec square x by 2 dx, which is equal to 2 dz. Now what is I1? So let us put these values in I1. I1 is equal to 1/4. And this is integration of, what is tan x by 2? Z into, what is sec square x by 2 dx? That is your 2 dz. Okay, so you can cancel this constant term, 2 1s are 2, 2 2s are 4. So now in the next step we have or I1 is equal to half, or I1 is equal to half integration of z dz, or I1 is equal to half into, what is integration of z? You know that this is z square by 2 plus c. What is integration of x to the power n? X to the power n plus 1 divided by n plus 1. So it is z square by 2 plus c. Let us put the value for z, or I1 is equal to, this is 1/4, 2 2s are 4. What is z whole square? That is tan x by 2 whole square plus c, or I1 is equal to 1/4 tan square x by 2 plus c. So this is the value for I1. So now actually we are finding out the value for I1, actually we have to get the value for I, isn't it? Not I1. This is not the answer. So let us put this value of I1 in I. Okay. So let us write down the value for I here. So actually what is I? Since I is equal to, this is I1 plus half log within mod tan x by 2 plus tan x by 2 plus c, or I is equal to, now you have to put the value for I1. What is I1 here? 1/4 tan square x by 2. Again c, you don't have to put c out here because c is already written here. Only one c will do. Okay, एउटा constant integration एउटै मात्रै हाल्यो भने भइहाल्यो, दुईवटा constant integration हुनु पर्दैन. So don't write here c. Okay, so what is I1 here? 1/4 tan square x by 2 plus, what is the second term? Half log within mod, that is tan x by 2 plus, this is tan x by 2, then plus c. So this is the final answer. So I think you have understood it. So this question is quite complicated, but it's very, very important. You can revise it at home. So let's do the next question now. So now we'll do the next question, that is question number 25. The question is, you have to evaluate this integral, that is integration of 1 plus tan x divided by 1 minus tan x dx. So how will you evaluate this integration? So therefore I is equal to integration of 1 plus tan x divided by 1 minus tan x dx. So how can you evaluate this integration? So let us simplify it first. This tan x can be written in terms of sin x by cos x, isn't it? So let us write it in terms of sin and cos. So I is equal to integration of 1 plus, what is tan x here? It is sin x by cos x divided by 1 minus, again what is tan x? It is sin x by cos x dx. Okay, so you know how to simplify it. Let us take the LCM in both the numerator and the denominator. What's the LCM? Cos x. That cos x will be cancelled. So directly we can write it as integration of this is cos x plus sin x divided by, it is cos x minus sin x. Then what do we write? Dx. Is that clear now? So next, how will you evaluate this integration now? So let us differentiate the denominator. Let us check it. Are you getting the numerator after differentiation of denominator? Let us check it. So your denominator differentiate. What is the differentiation of cos x? Minus sin x. What is the differentiation of sin x? Cos x. So here minus is taken common. So it is cos x plus sin x, which is in the numerator. We are getting the numerator here by taking minus common out here. So let us assume this denominator as z. So let z is equal to, this is cos x minus sin x. Okay, so differentiating both the sides, with respect to x. So differentiating both the sides with respect to x. So differentiating both the sides with respect to x. So what do we get? Therefore, it is dz by dx is equal to, what is the differentiation of cos x? What is the differentiation of this cos x? Minus sin x. Let us write here minus sin x. And there is minus sign is there. What is the differentiation of sin x? Cos x. So it is cos x. Okay. Or dz is equal, let us cross multiply it, and here minus is common. So it is sin x plus cos x bracket closed. And what do we write? Dx. Okay. That means we are getting the numerator, but that minus sign should be taken to the left hand side. So or it is minus dz is equal to, this is your sin x plus cos x bracket closed dx. Is that understood now? So we have got the value of the numerator, that is cos x plus sin x into dx as minus dz. So let us put these values in I. So therefore I is equal to, this is integration of, what is cos x plus sin x dx? This is minus dz divided by what is cos x minus sin x? It is z. It is z, right? So or I is equal to, minus sign is taken outside. And what is integration of 1 by z? What is integration of 1 by z with respect to z? Or differentiation of which function is 1 by z? That is your log, isn't it? So log within mod z base e plus c. Now you can put the value for z. What is z actually? It is cos x minus sin x. Or I is equal to minus log within mod, what is the value for z? It is cos x minus sin x. It is cos x minus sin x, mod sign close plus c, and here the base is e. So this is the final answer. So I think you have understood the question. Okay, so you can copy it. Now we'll do the next question. So now let us do this integration, that is question number 26. Evaluate integral sine x to the power 4 minus 1 dx divided by x square root under x to the power 4 plus x square plus 1. So let us write here I is equal to this expression. So how will you evaluate this integration? So in this case, we do not know differentiation of which function is which one. We don't know. If we differentiate x to the power 4 plus x square plus 1, we are not getting this x to the power 4 minus 1 divided by x square. So here the different method is used. Okay. So here the method is let us simplify it. Okay. Integral sine x to the power 4 minus 1 dx divided by, this is your x square. Now from within square root you have to take common. So what is that common that you can take from the square root? X square. Okay. Let us take x square as common. So within bracket, what do we get? If x square is common here, so since this is x to the power 4, it should be x square plus x square is taken common 1 plus, since this is 1 upon x square. So I think you have understood it. Okay. So or I is equal to integration of, now this is x to the power 4 minus 1 dx divided by, now since here square root of x square is common here, what is square root of x square? It is x and it is multiplied by x square, so it is x cube, and this is root over x square plus 1 upon x square. So I think you have understood it. Okay. Or I is equal to integral of यो x cube लाई हामी माथि लगेर माथिकोसँग सिम्प्लिफाई गर्न सक्छौं. That is, you can write it as x to the power 4 minus 1 divided by x cube, then dx. Is that clear? Divided by, within square root, it is x square plus 1 upon x square plus 1. Is that understood now? So let us simplify it further. Or I is equal to integration of, now we can separate the term which is in the numerator. What is x to the power 4 by x cube? That is your x. We can separate the term. X to the power 4 by x cube is x minus 1 upon x cube dx, right? So whole divided by, within square root there is x square plus 1 upon x square plus 1. So now let us check the relation between the denominator and the numerator. Okay. So if you differentiate the expression within square root, what do we get? Let us check it. What is the differentiation of x square? It is 2x. What is the differentiation of 1 by x square? X square goes up in the numerator, x to the power minus 2. So its differentiation will be minus 2x to the power minus 3. So which is equal to, what is common here? 2 within bracket x minus, so it will be 1 upon x cube. This will be 1 upon x cube. That means we are getting the numerator. 2 is constant out here. If you take 2 as common, you will get x minus 1 upon x cube, which is in the numerator. That is, differentiation of the expression on the square root will give you the numerator. Since the square root is in the denominator, you can assume it as z square now. Is that clear? So let us assume this expression on the square root as z square. So it is x square plus 1 upon x square plus 1. So let us write here, differentiating both the sides with respect to x. So what is the differentiation of z square? It is 2z into dz by dx is equal to, what is the differentiation of x square? 2x. Then what is the differentiation of 1 upon x square? Now x square is taken to the numerator, make it x to the power minus 2. And what is this differentiation? Minus 2 becomes the coefficient, x to the power, decrease the power by 1, that is minus 3. Or now this is 2z dz by dx is equal to, 2 is taken common, within bracket what do we get? X minus 1 upon x cube. Here 2 gets cancels. Or now cross multiply it. So z dz is equal to, this is x minus 1 upon x cube bracket closed, then it is dx. That means we are getting the numerator as z dz, right? So therefore, what is I now? So I is equal to integration of, what is the value of this numerator, that is z dz, divided by, in the denominator, what is root over z square? That is your z. Here z gets cancels, or I is equal to integral sine dz. Clear? Next, what is integral sine dz? So I is equal to, what is integration dz? Integration dx means x. Integration dz means it is z plus c. Or I is equal to, what is the value for z? The value for z is square root. Since z square is equal to x square plus 1 upon x square plus 1, what is the value for z? It is within square root x square plus 1 upon x square plus 1 plus c. Okay, so let us simplify it. Or I is equal to, within square root, what's the LCM? Within square root, x square is the LCM. This becomes x to the power 4 plus 1 plus x square, then plus c. Or you can write it as, you can remove square root from the denominator. What is square root of x square? It is x. So square root is in the numerator only. So it is x to the power 4 plus x square plus 1. This whole divided by x. And this is plus c. So that is the final answer. So this question is very, very important. So you can mark it. So you can revise it at home. Okay. So now from the book, the problems are finished from this exercise. That is exercise 6a, page number 351, 5 mark section. This exercise is finished. Okay. So in the next online class, we will do standard integrals. Okay. Now let's do question from Madhyamik question paper. Okay. So if you can do the problems from Madhyamik, from HS question paper. This question is from HS question paper. Let's do questions from HS question paper. Okay. So let's do the work now. So now we'll do this question. So we'll do this HS 2016 2C number 2. Before that, these are your homework. I'll not give you the hint. You can do it yourself. Okay. So this is from HS 2020. This is your homework. 1C number 5. Evaluate. This question carries 2 marks. That is integration of cos x plus x sin x divided by x into x plus cos x dx. You can easily evaluate it. This is from HS 2018. This also carries 2 marks. This is also your homework. 1C number 6. Evaluate integral sine x plus 1 into e to the power x divided by cos square within bracket x e to the power x dx. This is your homework, right? Next one is homework 2C number 2. This question carries 4 marks. Evaluate integral sine dx divided by cos x plus root over 3 sin x. We have done this type of problem. You know it, how to do it, isn't it? So in this case, what is the coefficient of cos x? It is 1. What is the coefficient of sin x? It is root 3. So in the denominator, you have to multiply and divide it by square root of coefficient of cos x whole square plus coefficient of sin x whole square. That is root over 1 whole square plus root over 3 whole square, isn't it? So what is the method here? You have to multiply and divide the denominator by within square root coefficient of cos x whole square plus coefficient of sin x whole square. That is 1 whole square plus root over 3 whole square. That is under square root. You know how to do it. Okay. So do it at home. This question carries 4 marks. And this is from HS 2017. This is also homework. 1C number 3. Evaluate integral sine cos x minus cos 2x divided by 1 minus cos x dx. And this question carries 2 marks. Okay. Now let's do this question number 2C number 2 from HS 2016, which carries 4 marks. Let us evaluate integral sine e to the power x into x minus 4 upon x minus 2 whole cube dx. So let us write I is equal to integral sine e to the power x into x minus 4 divided by x minus 2 whole cube dx. Okay. So what is there in the denominator within whole cube? It is x minus 2. So let us write x minus 2 in the numerator also. Or I is equal to integral sine e to the power x into, now this is x minus 2. So x is correct, but there is minus 2, but here we have got minus 4. To make it minus 4, what will you write? Minus 2 divided by x minus 2 whole cube. Then what do we write? We write dx there. So let us keep it within second bracket. So let us separate the fraction within second bracket. I is equal to integration of e to the power x within second bracket. So now let us separate the term here. What is x minus 2 divided by x minus 2 whole cube? This will be 1 upon x minus 2 whole square, isn't it? Next, minus 2 upon x minus 2 whole cube. Then second bracket is closed. Then what do we write? dx. So I think you have understood it. So now let us check. Now in this case, let us check the relation between these two terms. What is the relation between first term and second term? Let us check it. So we know that differentiation of the first function is the second function. Let us check it. Let us differentiate the first function. dy dx of, it is 1 upon x minus 2 whole square. So let us check the differentiation of 1 upon x minus 2 whole square. Are you getting the second term or not? So which is equal to dy dx of, this is x minus 2 whole to the power minus 2. Okay. So what is this differentiation? Minus 2 becomes the coefficient. Then x minus 2 whole to the power minus 3 into differentiate x minus 2 with respect to x, which is 1. So which is equal to minus 2 divided by x minus 2 whole cube. That means we are getting the second term. If you differentiate the first term, we are getting the second term. Is that clear? So let us first multiply by e to the power x here. Or I is equal to integration of within second bracket e to the power x upon x minus 2 whole square minus 2 e to the power x divided by x minus 2 whole cube, second bracket close, dx. Okay. Now since the differentiation of this first function is the second function, we can assume this first term including e to the power x as z. So let us assume, let z is equal to e to the power x upon x minus 2 whole square. So I think you have understood it. You can copy it. So in the next step, what will you do? So now in the next step, you can differentiate both the sides with respect to x. Okay. So differentiating. So this is the next step. Differentiating both the sides. Differentiating both the sides with respect to x. Okay. So this is dz by dx is equal to, which rule is used here? U by v rule. You know U by v rule, isn't it? So what is U by v rule here? Now difference, that is denominator is kept as it is. Keeping denominator as it is, that is x minus 2 whole square. Take the differentiation of the numerator. What is the differentiation of e to the power x? E to the power x minus, now numerator e to the power x is kept as it is, into, take the differentiation of the denominator. That is, what is the differentiation of x minus 2 whole square? What is the differentiation of x minus 2 whole square? It is 2 into x minus 2 whole to the power 1 into, what is the differentiation of x minus 2? That is also 1. Okay. So into 1, you don't have to write it. So whole divided by, so you know U by v rule, whole divided by denominator whole square. That is, denominator whole square means x minus 2 whole square, again whole square. So it is x minus 2 whole to the power 4. Understood now? So now let us separate the term now, or dz by dx. So let us separate the term here. X minus 2 whole square e to the power x divided by x minus 2 whole to the power 4. You can cancel here. E to the power x divided by x minus 2 whole square. Then comes minus sign. Then 2 e to the power x divided by, you can cancel here x minus 2 by x minus, you can cancel x minus 2 whole to the power 4 by x minus 2. You can cancel x minus 2 whole to the power 4 by x minus 2. What do we get? This is x minus 2 whole cube. Is that understood? That means we are getting this expression, isn't it? That is e to the power x over x minus 2 whole square minus 2 e to the power x divided by x minus 2 whole cube. We are getting this one. So now cross multiply by dx here, or dz is equal to, within second bracket, e to the power x upon x minus 2 whole square minus 2 e to the power x upon x minus 2 whole cube, second bracket closed. Then you can write dx. So what is the value of this whole expression including dx? That is your dz. Okay? That is e to the power x upon x minus 2 whole square minus 2 e to the power x upon x minus 2 whole cube, dx is equal to dz. So therefore I is equal to integral sign. So instead of this expression you can write dz. Okay? So or I is equal to, this is your z plus c. This is your z plus c. What is the value for z? Or I is equal to, what is the value for z now? It is e to the power x upon, this is x minus 2 whole square. This is x minus 2 whole square plus c. So this is the final answer. So I think you have understood it. So you have to do this homework. You do this as homework, and you can revise it at home, because this is very, very important question. These questions are also very, very important. You can do it at home and you can revise this problem at home. त आज हामीले जति पनि प्रब्लम्सहरु गर्यौं यो सबै तिमीले घरमा रिभिजन गर्नु. So we have finished this chapter, integration by the method of substitution. That is, we have finished this exercise 6a. So in the next online class we will do the new chapter, that is standard integrals. So this much is for today.